I want to talk about how to write JavaScript, but with one little difference. No letters or numbers allowed. If you take this block of code, plug it into Firefox, you will get an alert box. This is completely legit JavaScript right here.
Obfuscated JavaScript? Is that what we're
This is very obfuscated. So the question might come up, why? Well, it actually came up from a real-life scenario where you had a filter that was blocking alphanumeric characters but not symbols. It can defeat some of the different, sanitized script versions. I know it's been used to break Facebooks. May not be as easily detected. It's kind of a think outside the box exercise, and of course that comes to the real answer, because we can. So, just a little history. This began on Slackers. There's several threads there about it. OWASP did a contest last year. That's how I started learning this, where that's actually that first block of code was you had a shortest block of code, no non-alphanumeric to alert the word OWASP. There's a whole forum on Slackers now on obfuscation. There's several threads there, and I'll have links to the end. This is not my doing. Like, what you're seeing is I have learned this from the masters. These guys here have done a lot of development on this, and I completely yield to their expertise in all these. Lever One in particular just has a way of optimizing everything that I come up with. So, basic ideas behind this. First of all, variable names don't have to be letters to start with in JavaScript. You can pick Unicode symbols. You can do, underline or, of course, the little jQuery $sign there, so that's helpful. A key aspect of JavaScript is the dynamic weak typing, and you can type convert till the day is long. It's very flexible with the primitive type, so if you just take some variable and plug it into a situation where it's a different data type, JavaScript will do everything it can to just convert it to the new data type and keep going. So you can see here, all it takes is just put a plus mark in front of that string there, you get a number back, put a not operator on the 0, and you get a Boolean out of it. So that's something that comes in very handy. This is just a little trick to be aware of. If you start combining arrays or objects, those end up concatenating. That can be an easy way to get certain strings sometimes. And this is another very key aspect of it. If you have a string in JavaScript, you can treat it like an array to pull off individual letters. So here the 0th character is T, first character is E, and then of course you can recombine all of those letters using concatenation to get a new string out of it. So if you have one string to start with, you can build other strings using the individual letters. So with objects and with methods and properties also of objects, typically you see the dot notation, window.alert when you're doing JavaScript, but you can also treat them like arrays also and access the objects that way by calling them as a string. And so that becomes very important later on. So this is just kind of a reference slide, an example of some of the different type conversions that happen. And you can see right away some of these, like the not empty string is true, no letters or numbers there, plus brackets plus array is 0. So there's some ways you can get some basic values just by using some of these empty primitive types. So to start off with, let's try to get some numbers. So an easy way to do that is starting with an array or a string gives you a 0. And then we can assign that to a variable if we want. I just chose the degree symbol here. And then you have all the different operators at your disposal. So you can do increment before, increment after, you can do division, you can negate it, you can also do decrement operators. JavaScript has a weird little tilde which adds 1 and makes it negative, and multiplication. So you can see starting with the 0 here, we can use all these operators to basically get any number we want. If we just keep adding to it or moving things around, you can even concatenate together to get some of the larger numbers more easily. So the next step would be to get strings. So one way I like to start is just with an empty string. If you're concerned about quote marks, there are other ways to get strings. You don't have to start with this one, as you'll see in a second. So here we take change that to a Boolean, take the not, we get a true, add a blank object to it. Since we concatenate them, JavaScript changes it all to a string, and we get this true object. So now all of a sudden we have some letters at our disposal that we can pull off this string. We haven't used any letters so far, but we can pull them off using that array notation. If we take the Boolean of that and then add a string to it, we'll get the word false. If we just took the Boolean, then JavaScript's not going to treat it like a string when we're trying to pull letters off of it, so we actually have to concatenate another string to it just to make sure we get the right data type. Then we'll go ahead and establish our starting number here. And so now we can start pulling off letters. From our first string, if we pull off the 0th one, we get a T. These are actually Unicode symbols. You can see little marks on top. Next character over is an R. We can pull off an S off of our false. This again, we've got 1, increment by 2, so that's the third one. And then do another one to get 5, and we can pull an O off. And so just from these letters right here, you can see that we've now spelled out the word sort. So if we were to apply that then to just a blank array, we would get a reference to the sort function. Now we're not actually calling the function yet. There's no parentheses here. We're not executing. It's just getting a reference to it. So it really doesn't matter what is in the array to start with. We're just getting the function from any old array. So in that first array, we can do all of our assignments to establish these values. Colors are just to make it a little more readable. So in our first array, we just do a whole list of all those statements that we just saw, stick in our string at the very end there, and now we have a reference to the sort function without ever using any letters or numbers. And of course, there's a lot of optimization you can do. This is just kind of an example where you can nest several of these declarations to shorten things up and make it go a lot quicker. So one thing to remember, though, we're building all these strings and stuff, but it said here, alert the string and alert in an array are not actually the alert function. So you can't just like use this to say alert and go to town. All we're doing here is we're getting words, we're getting strings. And so this is where that idea of the array notation, access properties, and methods becomes important. So the reason I chose sort as an example to start with is because in Firefox, if you get a reference to the sort function, call it on nothing, you actually get the window object back. So this is an example where using that code we just had, we can assign that to a variable, execute the function, and we'll have a window object which we can then access things like alert or other stuff.
Had you set X to just be the empty array, would it have also called the window function?
Like just X equals array?
Yeah.
You would have gotten an error because then X wouldn't be a function if you tried to call X parentheses. There's certain places where the window object kind of leaks out.
Gotcha.
I'm not exactly sure what the logic, like this is a Firefox only one, but sort is one of the quickest things you can get using these letters that you start with. So it's very easy to build just a short little bit of code in Firefox. One nice thing in Firefox for some of the contests that went on is you can actually use base 64, and usually if you're going back to letters, the characters you convert from are not alphanumeric, so it still works pretty well. Firefox actually has a neat little trick for assignment where if you assign an array to a string like this, then you just get each individual letter. So that can be a really quick way to pull off those letters rather than having to do the array notation for each one. Beginning back to all browsers, another way you can pull off window is by getting a reference to concat, calling it blank, and selecting the 0th element, you get window back. Another way is if you get a reference to value of, call it on a blank, you'll get window. There's a bunch of other ways to do this. There's a whole thread on Slackers of ways to get the window object, just in all different browsers. So there's definitely other ways of doing it. These are the concat one is usually the simplest if you're going cross-browser.
That works for Chrome too?
Yes, works for Chrome. So now that we have window, what next? Well, if we wanted to use eval, we would need to get a v in order to build a string to call that function. One way we could do that is if you just convert a function of one of the built-in functions to a string, it usually shows up as function, function name, native code. This is in basically every browser does this. So that's where we can pull our v off. Sometimes it might be in a different place depending on the browser, but it works. But getting some of the letters can be really difficult. To start with here, we only had basically 12 letters to work off of, but we can get others. If you get infinity, that'll give you an N. You can call the constructor on a regexp object, and you'll be able to get the P out of it from the name there. But again, remember, you're going to have to build this whole long string constructor, so it can take some code to do that. It would be nice if we could just like call string from char code, but if we're going to call this function, we already have to have H and we have to have C in order to get a reference to that function. And those are pretty hard, if not impossible, to come by. Some of these letters, I don't think anyone's found a way to get just from the basic primitive objects yet.
Hopefully this doesn't sound
It is case sensitive.
Question, can you build, so for the CMH, can you build something that can go and pull it from another data type that's common?
Like what?
So like a known site, known program, known routing component?
That's basically like you see here with getting regexp constructor, infinity. That's what people have been trying to do, and there's some letters where people just have not found. I mean, I've been through MDC several times looking for particular letters, just any way I can get a specific letter, and I haven't been able to find one. One is actually H, which we'll come back to in a second. So one thing that would be really nice, though, is if there was somewhere else under our control where we can insert some of these characters and then pull from that. Well, actually, since we're working client side, we do have things at our disposal, such as window.name, and of course the hash of the URI. We can plug in basically whatever we want there. That's loaded on the client side, and we can actually get access to more information. So an example of that, if you set the window name to alert, and then call eval the name, basically using this, if you can get window eval and you have access to the name, then you can execute any code you want. You don't have to worry about being non-alphanumeric anymore. Just your actual payload and a cross-site scripting vulnerability would be non-alphanumeric.
Is there a built-in MD5 hashing algorithm?
Not in JavaScript.
Because I was thinking you might be able to either MD5 or SHA or something like that, do a hash on of a known string which is going to give you back a known group of letters.
That's kind of like with Firefox and the beta A function. It's using base 64. So if you know that this certain block will give you these letters back, you could do that.
Can you subtract?
But again, that's Firefox only. Do what?
Can you subtract letters from each other? Like, can you subtract like?
JavaScript does not have real sophisticated string operations. Like I haven't found a way to just manipulate a letter and like bit shift it or something. Yeah,
JavaScript is weakly typed,
it is.
so as long as the cast makes sense, you're going to be able to do it.
Right.
My thing is, like, there's a few Firefox add-ons that can do like base 64 checks and whatnot. I forgot the name of it. There's so many different add-ons that you can get. Like one is like Firebug or whatever, and then there's another
Right.
one that does base 64 as well.
Yeah, but if you're wanting to hit end users with this, they're probably not going to have any of those add-ons.
Okay.
So I mean,
You want it to work on the base install the option.
right. But with here, since we have access to the name of the window, we're at the point now where we can execute anything we want. We don't have to worry about grabbing all those letters. If we can just get to eval, we're good to go. Another way of doing it is if you actually include JavaScript code in the beginning, set the location to the window name. You'll get the same effect. One thing though, M can be a little difficult to get sometimes. It kind of takes some doing to get, usually it's number constructor. Another option would be to use the hash, plug something in there and just set location equals location hash. But here's where we run into another little obstacles that, like I said, getting the letter H, I don't know of a way to get the letter H just using this basic stuff like I've been talking about. But of course the hash is already part of window location, which we do have access to. So it'd be really nice if there was some way we could just pull out that hash, and of course regular expressions come to the rescue. Because to do regular expressions, we don't really need anything more than just symbols. So for some shorthand, I'm going to go ahead and assign a window object and the string location. These next few examples. So if this is my hash, I can call window location equals, that regular expression will get me the hash out of it. So again, using only symbols, I can pull out that little bit, set the location there, and execute anything I want. Actually, you don't even need regular expressions, though, if you use some little tricks. If you want a comment out part, again, these are just symbols, not using any more letters here. So you can eval, tack that onto the beginning. You're basically commenting out the first part of the URI, and then you only execute what comes after it in the hash. It's just a comment. So the slash asterisk and the closing asterisk slash in JavaScript are just commenting out that part of the code. So the only thing it actually executes is what follows the comment. So this isn't actually regular expressions here. This is just doing a straight eval. Another way, this is one that Lever1 came up with that was pretty clever, where, again, since getting the V for eval can be hard, getting slice is a lot easier, and you can actually just, again, put eval inside of your hash, load it up, and then execute the rest of it from your hash there.
So you'll find this exact slice that you're looking
This is using the slice function to pull off part of the string there. So the slice -4 pulls eval out. Now you have the eval string. You don't have to worry about getting it manually letter by letter. And then you execute it on the rest of the URI, and the comments block everything else from loading.
Most of what you're talking about work on any weakly typed language.
Yes.
If these functions are there and this syntax is there, it'll work.
Right, and so the key is getting the functions.
Yeah.
And that's where those first steps come in, and building on it. Of course, this is just showing you what you're trying to do. But of course, there'd be a lot more code in actually getting to those strings. And that's why the last one, it's easier to get slice than it is to get eval. It just takes less code to do it. But of course, it's nice to optimize down. These can get pretty complicated. This kind of first started with a contest in Slackers to execute alert 1 in Firefox as short as possible. The first entry was 472 characters long, because it takes a while to build all this out. Any guesses as to what the final version came down to? 128. Very close. It was 63 characters. So that's all it took to load up an alert 1 using no letters and numbers. Later, another version was done where it's using the window.name or location hash ideas to load arbitrary code. So this is to execute anything without using the base 64 stuff. First one was 154. Any guesses on the final? 103. For the cross-browser version, first one to execute arbitrary code took 240 characters. Any guesses on the final?
Has to be half of that.
70%.
You can fit it in a text message. So 160 characters, completely non-alphanumeric, and you can load up any JavaScript you want.
So,
Cross-browser.
quick question. So, was any of this weaponized? Because I've never seen. I look at a lot of. I look at this on a regular basis, and I surely haven't seen. I mean, I've seen obfuscation of any type, but I've never seen anything.
I'm not aware of anyone using this in the wild.
Yeah.
Yeah. This has been pretty like the five guys I mentioned at the beginning. Like, they've done a lot of discussion about it. I've joined in on some of the discussion, but it hasn't really gotten past
I saw
Slackers.
some of that in like a malware sample, like what?
What about these Twitter attacks?
Do what?
Aren't they less than
Well,
that?
your weakly typed languages, a lot of the developers know, don't let this run with, gratis rights.
You must not let the developers out.
Have you looked at the drive-by downloads that you know how you click it and then you get honed from downloading some bullshit and then you're part of a botnet? My thing is they have to be less than 240 if they're using, to do a drive-by download. Wouldn't they? Because it's JavaScript.
What do you mean?
You know, like the pop-ups that you get and you click it?
Right.
Like Rogue AV. Yeah. Like the Rogue AV pop-ups, aren't they using JavaScript to execute those files?
Yeah.
Yeah, but those generally throw the kitchen sink at you of vulnerabilities.
That's true.
Yeah, but I'm
Right.
saying like
Right.
I'm talking about the arbitrary code. Like he's saying it's 240. Wouldn't it be less than that to like bypass if you were in a Firefox browser, you still get honed even in Firefox.
So if you use the obfuscated JavaScript just to load the code on the back end, right? So to get past
Right.
the web AV or whatever.
So this is your payload. If you have a cross-site scripting vulnerability, this is how many characters you had to insert, and then it actually will call code from like window name or the hash. And since it's calling code from there, the code you plug in there could then load up an external script file from your web server that could be as long as you want. So if you have this many characters, you can do anything.
Yeah, this filtering it only needs to get past, whatever, like the web application is doing some filtering on like an input.
And of course, remember the server never sees the hash or the window name, so it's never going to encounter that.
How much of this is working against NoScript in its most updated version?
I do not know. I have not tested against NoScript. Of course, if you're trying to inject this somewhere, NoScript is probably going to catch it anyway.
Yeah,
It just says.
Just turn off the scripting.
yeah.
Yeah.
That's what I'm saying, anything that tries to
Unless you, so again, I guess the point is that the whole competition is about updating the default browser.
Yeah, that's part of why we cross-browsing. Like Firefox is easier, but you can still do a cross-browser. Just takes a little more tweaking. So this is the more practical side. Like you can use this in attacks and stuff, but getting into more of the because we can side. There's this thing that the people on the forum have called the Great JavaScript Wall. So one question that came up in kind of doing all these different contests and seeing what was possible was we've been assigning variables using these characters that look like letters and everything like that. But of course, we can build each string from scratch. We don't have to use the variables, so we don't actually even need all those other characters. So the question came up, what's the smallest set of characters needed to execute arbitrary JavaScript? Now, a lot of these are going to be Firefox only just because it was easier and, you know, it wasn't really trying to weaponize anything. It was just to see if it could be done. So the first attempt that I think Gareth Hayes and Eduardo Vela did was using 8 characters, brackets plus comma, question mark, parentheses, and slash. This is what it looked like. This is completely legitimate JavaScript. Basically what this is doing is calling eval on part of the location. It's again using the little trick of commenting out part of the address in order to execute. So if you have this URI, you load up this JavaScript in Firefox, you will get an alert 1. But it didn't stop there. It's reduced down to 7 characters. How many of you think you can go further?
Me.
There are several different ways of doing it with 6 characters. These are just a few of the different sets. How many think you can go further?
Me.
Unfortunately, no. This is the wall. Because what it comes down to, you're pretty much always going to have your array notation, your concatenation. I mean, you can't get around using that. Then this will, using just those, you can get undefined, infinity, and not a number. So you have certain letters that you can work with. But if you want to actually execute a function, you're going to add parentheses, so that's going to bring you up to 5, but you still have to have true and false to get enough letters to actually do anything. Using just the first line of letters, you're not going to be able to get any interesting functions, which will then give you window. The other option is to use the equal sign, so you can do like location equals, but then about the only way to get a window object is going to involve like parent or proto, which is going to require a P, which means you need regexp, you need the slash mark, and then you need the underline for the double underlines on either side.
Can you still hide the window so the end user can't see it?
Yeah, I mean, you can do anything you want. You can arbitrary JavaScript, so once you load up,
So
yeah.
the equals here is actually assignment, not equality.
Yes. Right, because you would use the equals to say window.location equals, and then your script. Of course, you can also use it to do Booleans, you know, to get some Boolean values. So that's how you can get your true false in this case, is using the comparison operator. So once again, optimizing this, the first code using 8 characters was 2,084 characters long. The first attempt using a set of 6 was 3,767, because of course it takes more to, you know, get all these different values. So after some refinement and optimization, the shortest attempt so far with a set of 6, and again, this Firefox only has. Any guesses? 1024, 1500.
24
Try 460. This right here is completely legit JavaScript. It's array parent location equals array parent name. Again, this is only Firefox does the array parent value like that to get a window. So this will load up whatever you want. 460 characters, 6 characters.
This is the beauty of weakly typed languages.
Exactly.
IDSs suck.
This is what IDS
No, but my thing is like if you try to put this JavaScript tag against like a different web application firewall or some shit like that, would it pick it up even?
That's a good question.
What, do you have a signature for that? I mean, you could, but
I mean that's retarded looking. I mean I don't know how you
Like I said, I know Gareth Hayes said that he used this against Facebook's JavaScript. Oh, this is Lever One's. This is not my doing. Like I said, he is way beyond my skills.
I thought you came up with that.
No, I'm not that good. The very first slide was one that I came up with. But.
All the evaluations inside the brackets are different.
What do you mean?
There
It's
is
not one single same pattern.
that's correct.
Yeah.
These are legit variables under JavaScript specs.
And there's a lot of
Legit
optimization.
variable names.
There's a lot of optimization going on in terms of, and Lever One is great at this, in terms of using numbers, where like you start with this value, add this much, multiply, divide, like keeping track of your numbers as you go along.
How much
Because for each character, you have to get stuff. Do what?
Why does Coke have to come into this?
So here's the real trick, right? So if you do to that what all the real malware authors do, which is encode it, decode it 15 different fucking ways before you actually payload it.
Yeah.
I don't know. I mean, has this been?
Are you
said it hasn't been weaponized, right? So if you turn that into hex or binary and throw it directly in an application or a browser or whatever, is it going to get detected by modern IPS or AP or whatever?
That's a good question.
No way.
Because it's going to see the hex and be like, oh, this is just a bunch of fucking equal signs and shit.
Like I know some of this has been used in a Facebook app. If you're gonna like load JavaScript, they filter it out and like make sure you don't have direct access to window and everything. But there's examples of this kind of code that you can throw at Facebook and you can get around their filters. I don't know if you still can. They might have blocked it now.
API is flawed in itself. Like it has some rudimentary flaws that you can.
Oh, don't get me started on Facebook. Oh, I forgot to mention at the beginning, but in case you don't know, I'm Joey Tyson, but probably better known as the Harmony guy. So I meant to say at the beginning. So yeah, Facebook and I go way back.
When it was the Facebook.
So you went and saw the social network this weekend, right?
I haven't seen it yet. I was not planning to because I was like, Facebook movie, whatever. And now it's getting all these awesome reviews. So
I went and saw it, and I actually really enjoyed it.
yeah, I've heard it's good. So I might do that.
I'm gonna go see it.
So if you're interested in finding out more about this stuff, there's the forum on Slackers for obfuscation. There's a bunch of threads on there. I did a post on Gemini's. Well, I work at Gemini Security with Peter, Laura, Georgia. I did a post on the company blog one day about this and linked to a few of the more important Slackers threads about this. Four of the guys that I mentioned at the beginning have actually written a book called Web Application Obfuscation. It's going to be available in this year. I thought it was going to be available like in November. Last checked Amazon, they said it was like December 31st. So I don't remember off the top of my head.
It's not O'Reilly or
It's
Wesley or something.
what's funny is the subtitle of the book is like // web, like this. It's almost like they're trying to cross-site script Amazon, but I can get that info for you if you want. But I mean, those are the authors right there.
It's gonna phone some fucking site.
So that's all I got. Y'all have a great night.